Ladies and gentlemen, we are continuing. We are going to look at 1.2, 1.3 November 2024 final paper. 1.2, let's go. We are given that Z1 is 12,4 is 45 degrees. Z2 equals to cos 75 degrees plus J sine 75 degrees. Apologies for referring to it as I up there, or in the first section of the question. We'll stick to J because it's J. All right, and then Z3 equals to negative 2 cis 30 degrees. All right, we are supposed to calculate Z4. Z4, which is Z1 times Z2 over Z3. All right, let's see. Z1 is in polar form with a cis. Z2 is in polar form but with a longer version of the cis, and Z3 is in polar form. So the best way to write it down is to change this Z2 also to be a cis. We are going to substitute, but we are going to substitute Z2 as a cis instead of the long version of the cis. So I have 12,4 cis 45 degrees. That's Z1. Z2, instead of cos 75 plus I sine 75, my R is 1, my theta is 75, so I'm going to write it as cis 75 with R, the modulus being 1, the argument being 75, then all over Z3, which is negative 2 cis 30 degrees. All right, we are what do our laws say with regard to multiplying in polar form? You're multiplying complex numbers in polar form, you multiply the r's, the modulus or moduli, then you add the arguments. So we're going to start on top. We are going to multiply 12.4 times 1, 12.4. Right. Okay, then cis 45 plus 75, 45, excuse me, it's 45 degrees plus 75 degrees, then over negative 2 cis 30 degrees. All right, continue. Let's add 12,4 cis 45 plus 75. That gives you 120 degrees over negative 2 cis 30. Now we are looking at no longer at multiplication. We are now looking at division. So what do you do with division? You divide your moduli, you add your arguments. So 12,4 divided by negative 2, that gives you negative 6.2. Cis 120 minus 30, that gives you cis 90 degrees. All right. We are asked, so we are done, but now we are asked to leave it in rectangular form, meaning we must change it to rectangular form. Using, how do we change rectangular form? We use the longer version of the cis, which is Z equals to R into cos theta plus I sine theta. We're changing from polar, to rectangular by using the longer version of the polar form. All right, so our r here is, our r will be negative 6 comma 2, then cos 90 degrees plus I sine 90 degrees. So this is a special angle 90 degrees. You don't need a calculator. You can simply go straight into it. So it's negative 6 comma 2. The cos of 90 degrees is 0. The sine of 90 degrees is 1. So I'm gonna have 1i. This is 1i, or simply I. Then multiplying out, I'll have negative 6 comma 2 times 0, that's 0. Negative 6 comma 2 times I, that's negative 6 comma 2 I. Now it's perfect in rectangular form. Get your 4 marks. Let's work, guys. Complex numbers, it's where we get our marks. Complex numbers, we get a pure 30, nothing less. Pure 30 complex numbers. If you are still struggling, work. Ask questions. Join a groups. Work. All right. We are going to 1.3. Awesome. Okay. And I have to bring my image down so you can see what we are doing properly. All right. There's my image. Okay. So what's the question saying? Given z equals to bi plus a, or a plus bi. Given z equals to bi plus a, then we have our Argand diagram on the complex plane, where we have the coordinate of our Argand diagram. Calculate the values of r and a. So what does the Argand diagram give us? We know that the first one, the negative 3, represents our a. So it represents our real part of the complex number. So we are going to change this to z equals to, our a is negative 3. Then the second coordinate represents our imaginary part, so our b. So it's negative 3 minus 3 over 2i. And that's what we are going to use to find r and theta. Let's go straight into it. We are at 1.3.1, apologies. So our r is equals to the square root of a squared plus b squared. All right, that's the square root of negative 3 squared plus negative 3 over 9 squared equals to the square root of 9 plus, the square of 9, the square, yes, the square root of 9, I'm right. Then plus square root of 9 plus, what have I done here? I made a mistake here. My mind is thinking ahead. Okay, let's erase this. Thank you. So it's negative 3 over 2. All right. Don't rush like mem rushed. Okay, plus negative 9 squared is 9. 2 squared is 4. If we are to compute that, we have 45 over 4. So it's the square root of 45 over 4. Then what's the square root of that? All right, let's find the square root of 45 over 4. Simplifying SATs, on top. The square root of 45, I'm not going to go into detail how we do it. The square root of 45 is 3 root 5. I'm sure you are aware of how to simplify sets. Then the square root of 4 is a 2. All right, then we go to theta. Theta, how do you get theta? You first look at which quadrant is our Argand diagram. In quadrant 1, 2, 3. In quadrant 3, where theta equals to 180 degrees plus arctan B over A. So I'm gonna have 180 degrees plus arctan. Our B is, when doing this, we said we ignore our signs, right? So we're going to ignore our signs. B will be 3 over 2, then over A will be 3. Then the arctan of that of 3 is 180 degrees plus the arctan of a half, 180 degrees plus the arctan of a half. Okay, this is okay. I'm tempted to go deeper, but I don't want to go deeper. So the answer gives you 206,565 degrees. That's your 15 marks done. Please stay tuned for our next lesson tackling question 2 of the paper.